Welcome to the Technology and Practice session for the Data Innovation Summit 2026 from OneData. This demo session is entitled From Chaos to Clarity, Data Products for KPIs, Reporting, and AI You Can Rely On. I will quickly guide you through our challenges and benefits that we seek with our software. I will then guide you through a short demo showcase where I will focus on the AI automation capabilities in generating code in an underlying process engine in the case of Databricks. And in the end, I will summarize the insights. Let's jump into the challenges and the gains that we try to achieve. Over the 10 years in the market and having conducted a profound discovery with our clients and customers and a market research, we basically pinpoint 3 customer pains currently. They break down to unreliable data that we want to turn into trusted data. So this core pillar basically is evolving around trust and trusted data. The second pillar is about right data with the wrong outcome. So therefore, we try to establish an alignment which basically supports the collaboration between data, IT, and business teams in order to result and produce the right context. And the third pillar is about the manual work overload that especially data engineering teams do face today. This is where the whole AI automation, our automation packages, as we call them, come into play that build very profound code in process engines based on the context that our software provides. How are we doing this? Basically, we have multiple capabilities in our software that are focusing on these 3 pillars of problems. We base our software on established concepts such as data products, data contracts, lineage information in order to produce a contextual semantic layer that basically is the foundation for all AI automation when it comes to code generation. So you can think of OneData as a modular software that bases its technical insights on the ingestion of metadata. So we are capable of ingesting metadata from multiple technical data catalogs, such as the Unity catalog from Databricks, such as Dataplex from BigQuery, but also established warehouses and databases. And we can integrate into process engines such as dbt, Databricks, or Dremio in order to leverage their transformation modules that we trigger with our automation packages. We are creating context in the form of data products and data contracts. We have a marketplace and a fully fledged lifecycle management when it comes to data products that I will showcase in the demo. This demo is focusing on code generation within Databricks. Let's jump into the demo. Welcome to the demo session. What you see now is the OneData data map after ingesting metadata from various source systems. The map creates hexagons that are a form of visualizing the metadata information within your source systems. The information can be ingested from multiple source systems and then clustered according to certain factors that are highly customizable. In this case or example, you see the clustering according to your organizational setup, according to subdivisions and business units. This is creating a first glimpse and visualization on your data asset portfolio. Furthermore, multiple data maps can be created, showing different kind of information. The map is overall searchable, so it's creating findability and traceability of your assets. And it can further be customized according to layers. So it's serving different stakeholders if the metadata information is available. Furthermore, it's also showing lineage information within your system or even cross-lineage information systems if the metadata information is available. Overall, our OneData map is paying into our trust pillar since the findability, traceability, and observability of your data assets and data products is achieved. Now that we have created the contextual technical information based on ingested metadata from various source systems, we now kick off the data product journey by creating a simple new data product. This we do from our data product marketplace, which basically aggregates all data products according to their status that are being managed or built within your organization. I'm creating this new data product from the perspective of the head of software engineering, and I'm interested in a short analysis of our Jira issues. So therefore, I'm triggering the data product draft workflow so we can specify a name for the data product and already create ownership by defining owner groups that can be customized in our software. Ownership and responsibility is a huge problem when we are speaking of data governance. So it's basically also possible to map and customize your potential RASI matrix that has been established in the data governance board of your organization. Therefore, we can define lead owners and lead producers of your data product. And we can basically give the data product a description. And we have multiple other contextual information such as purpose and limitation, which are basically important for the data contract that we see later. In this phase, we already have AI-supported capabilities in OneData that help the users create contextual information. We do also have the first indications of the data contract in the sense of data freshness. So basically, we can define that we want to have this information on a monthly basis, and we would kind of like also have the possibility to create a schema for your data product. This is also AI supported, so the system can give you a suggestion for your schema definition based on the contextual information it has so far. So the AI came back with an information that we accept. And the AI also has produced us a potential suggestion for the column definitions for our data product. So far, we will save it and accept it. And we also, based on this information, will create AI suggestions for the quality requirements of these columns. So therefore, also our system is capable of retrieving all the contextual information in order to suggest quality requirements that later will be automatically turned into data quality checks within Databricks. So the system has also created suggestions for the quality requirements that we will save. And in this moment, we also are creating a first data contract, which basically also carries the versioning of the data product, which we can see here. The data contract is structured according to the Open Data Contract standard and can be copied and downloaded as a YAML file for further exchange. We have specified our data product. We then can look into our asset library that we get from the ingested metadata information and can help the system with so-called supporting assets that should be regarded in the code automation and transformation that we want to achieve. Therefore, I'm selecting supporting assets, in this case, the Jira issues and the Jira projects, which should be regarded as assets in the transformation. Then I can basically, in the prompt style, specify the development specifications. I basically say that data quality checks should be written based on the data quality requirements. And then I'm choosing my automation package, which is the automation package for Databricks. As mentioned in the introduction, it's also possible to customize multiple automation packages for multiple underlying process engine technologies, such as Databricks dbt Dremio. We're now choosing the automation package for Databricks, and then we trigger the AI automation building of the code and the data quality checks. So the system starts our orchestrated agents that are running in the background in order to produce the code in Databricks and the code for data quality checks. After the automation package has finished, the code is generated in Databricks for a specified landing zone, which then can be looked at in the form of notebooks that have been created, which deliver the code for the actual transformations. So you can check the code here. This code is generated on templates that can be also specified within the agent model. And we have a second notebook for the actual quality checks that have been created automatically based on the data quality requirements that were specified in the data product. Now, if you're jumping back into OneData, we also retrieve the information here. Now that you have seen that our agents have been producing the code in Databricks for the actual transformation and the code for the data quality checks based on our quality requirements, we do see here now that the automation package has run successfully in OneData. We also do provide a profound logging and the traceable information what the agents have been doing. As I mentioned, it's an orchestration of multiple agents that are producing the code. So therefore, we have a very detailed information on how this code was generated. We can check this, and then basically we can also check on the data that has been produced, and then we are capable of actually reviewing the data product from a business perspective, and then we can decide that we are publishing this data product. So you see that this data product went through multiple iterations. OneData also serves a highly sophisticated versioning system where we do have a logic of major, minor, and patch, which can be also customizable. So this is also aligned with the data contract. So we also have the versioning then on the data contract to have full traceability and trust in what happened to the data product. I now decide that from a business and technical perspective, this data product is correct, and I decide to publish this data product. So after the publication, this data product goes with a version 4 into our data product marketplace. I have showed you the case of a simple data product creation and management, but now we want to take it to a complex scenario. One point that we want to solve with our software is the alignment and the collaboration between multiple stakeholders in complex scenarios. Therefore, we have our use case blueprinter, which establishes this collaboration and is creating context information across multiple teams and for the overall use case that should be tackled. Again, I'm creating this use case from a perspective of a head of software engineer. So my use case is that I want to give a Jira management reporting, and I can create this use case by also giving a profound description of this use case. So our use case is basically the description from a problem or challenge perspective that I want to have solved. I can also give the use case a clear business value that I want to achieve. This is basically important when it comes to prioritization of use cases. And then I can start to actually design my use case or my solution with multiple stakeholders in dedicated sessions. Therefore, the system provides you some placeholders that you can use. So you can imagine the canvas being a clever, smart Miro that is basically retrieving all your asset information and contextual information onto the canvas. So basically, we're starting this by creating a potential dashboard that we want to use in our management readouts, and that can be a potential solution for the use case, which we call the executive delivery overview dashboard. It can also have a description, so it's clear what the requirements are from the business side. So you can think of that this could be, for example, also multiple dashboard. It can also be one dashboard. And then within the collaboration of your stakeholders from the data and IT side, the canvas also enables you to look into the asset library that comes from the ingested metadata, and we can basically design our solution that leads to the creation of the dashboard. So we might have already a data product which describes the Jira projects, but we also have multiple assets that we ingested that we could use, for example, the Jira issue activity. And these data products and asset then can be linked into a lineage that is needed to produce the actual KPIs and insights on the dashboard. Now you can imagine that for certain use cases, the solutions can be highly complex. So the canvas provides you a tool that achieves collaboration across multiple stakeholders and multiple teams that actually model your solution. The modeling is basically based on the assets that can be retrieved from the library, but also based on data products that can be used that have been established. The canvas also provides certain functionality that help you model your solution. So basically here, the placeholder team performance is interlinked with the asset Jira projects, and the system can provide you the function add from lineage. So this is kind of like then establishing the column definitions for a potential data product that is needed to feed into the dashboard. Furthermore, you can also look up and replace the placeholder with a data product that has been already established. And the system also has AI capabilities in providing recommendations based on your data product marketplace and asset library. So at some point, the lineage will be finished, and through the automation package, the data products can be built. So you can imagine that multiple use cases are basically established within your organization, within multiple business domains. So we have the possibility with our use case overview that we can search, sort, and filter use cases accordingly. So basically, we're creating contextual information from the use cases, from the business, down to the technical assets. So we're interlinking the semantic information with the technical information that we retrieve from the metadata of the assets. We furthermore have the possibility to retrieve data quality checks and the contract statuses fully automized. We can aggregate these information on a data health dashboard across your business domain or organizational unit, which is extremely helpful and interesting for data product managers or data product owners that are managing multiple or larger data product portfolios. And in the end, to close this demo, we then can also provide the information again on quality, basically on our map in a layer where we can basically show the quality information based on the data quality checks and data contract information on the map in order again to pay into the trust pillar to produce trusted, high qualitative and governed data for your underlying solutions. Thank you for listening in for the demo part. Now I want to quickly summarize what I just have showed you. I showed you our software OneData, which is basically a modular software platform building on well-established concepts such as data products and data contracts. The demo especially highlighted the automation capabilities of OneData. In the example of Databricks, I showed you that our system can produce valid and trusted transformational code in Databricks, as well as code for data quality checks. These data quality checks can be run from Databricks and retrieved from OneData automatically and be shown on data product level as well as on the data health dashboard as seen in the demo. OneData builds on multiple capabilities that produce structure, context, and business logic for your data products. In the end, we want to turn challenges and problems into gains. Therefore, we are aiming to create trust, alignment, and AI automation for your organization. If you are interested in an exchange and want to see the demo in real life, please scan the code and see us at our booth on the Data Innovation Summit 2026. We're very much looking forward to your visit. See you there.